Yes, well, my name is Hayden, working on the wide performance variation of REBCO coated conductors. I did this research with Nonoku and my mentor, Aisha. Thanks to the project leads, Matt, Tak, and David, and special thanks to Dima, Van, Jonathan, and Cade. So, what is REBCO? REBCO is a superconductor that's created in a layered architecture. So it's created with all these different layers. The REBCO itself is only about 2% of the total thickness. However, it's a very important material because it has one of the highest critical current engineering densities, meaning that it's very good for magnet applications. So things like the MagLab's own 32T superconducting magnet, the little big coil, and other common high field applications. Some challenges with the material, however, are that thanks to some work Jonathan did, the current along the length of the tape varies. It's not consistent, and so we wanted to investigate spool-to-spool performance inconsistencies at specifically working conditions. We wanted to provide IC information, so critical current for magnet design and construction to improve those and understand how and why it varies. So for our study, we started with 7 different spools produced by the same manufacturer to the same specifications. So theoretically, they should be the same. This is just an example of what the spools look like. And different tests, characterization tests we did critical current density, critical temperature, angular dependence, and we looked at the microstructure. So what did we find? We found that at 1 Tesla and 77 Kelvin, there is quite a bit of variation between spools. Each of these lines is a different spool, and specifically at the peaks around 90 and 270 degrees, those are due to strong pinning forces within the REBCO to pin the vortices. And because of this variation, we see that there are different forces there are different pinning forces within the spools. Similarly, with the critical temperature, we found that there is a wide variation of the onset temperature. So the onset temperature is where the material starts to lose its superconductivity, and between the 7 spools, it ranged from 80 to 87 Kelvin. And even with the microstructure, just looking at images, not only did they vary between different spools, but within each spool, we found variation. So these 2 images are taken from the same spool, about 10 millimeters apart, and there is significant variation between those. Just to note, those particles within the images, those go into the REBCO layer, and by going into the layer, then they can stop the current from passing through, just cause blockages there. So they are not. So this variation is not great. So what we learned, we found that there is a lot of variation between spools, REBCO tapes, even if they are produced to the same specifications, and that REBCO is challenging to consistently make. There is a lot of variation, and sample performance at 77 Kelvin and self-field does not indicate homogeneity at working conditions, so at 20 Kelvin or 20 Tesla. Future analysis for this work, we plan to look at the length of along each tape, see how the current and the structure varies along the length. Look between manufacturers to help provide control for the process. But yeah, I've got some references, and thank you for listening.